So we have a parabola, the ball is being thrown, and it looks like this. Here's our parabola. And it hits these points, over 1, up 3, over 2, up 5, over 3, up 6. The very top of the wall is at 5, 6. Will the ball go over the wall? If not, will the ball hit the wall on the way up or the way down? Well, first of all, let's take a look at our equation. And now, please write these steps down. Step 1, enter the data in L1 and L2 of your calculator. Or you can do it longhand like we were doing in the previous pages. So in L1 and L2, you did this back in Chapter 3. You hit Stat and Edit. Clear out anything that's in there. We don't want anything in your L1 and L2. Your X's go in for L1. 1, 2, 3. Your Y's, 3, 5, 6. Okay, so you enter it into L1 and L2, making sure you put your X's in L1 and your Y's in L2. Again, this is repeat from Chapter 2. Number 2, you are going to hit Stat again, and just like you did before, you're going to go over to Calc. So you're going to hit Stat, go over to Calc. This time, you are used to linear regression because we studied straight lines, but now we're in quadratics, we're in parabolas. So you want to study quadratic regression. So you're going to pick number 5, quadratic regression, and it just says quadrag. Okay, so let's do that. You're going to hit enter until you see your variables. So enter until you see A, B, C, and hopefully R squared. If you don't have R squared, let me know. I'll help you get that on your calculator. In this problem, we get negative 0.5 for A, 3.5 for B, C, and 0, and R squared is 1. What this means is your 3 points make a perfect parabola, okay? These are the numbers that go into your equation. Let's make our equation. Y equals, you just kind of realize how much easier the past couple of pages could have been, huh? Negative 0.5x squared for ax squared plus bx, 3.5x, plus 0, okay? Now the question says the top of the wall is at, I'm way up here, it says the top of the wall is at 5, 6. So let's take a look. It goes to 1, 3, and then it goes to 2, 5, and then somewhere along the lines it goes to 3, 6. Now let's check out what happens, okay? So let's plug in 5 and see if we get out 6. So the wall happens at 5. Let's plug in 5 and see what happens when we plug in 5. So we're going to say y equals negative 0.5, 5 squared, because we're plugging in 5, because the problem asked us about 5, plus 3.5 times 5 plus 0. Ready? Negative 0.5. I'm going to bring that down because some of you are probably still copying. There you go. Parenthesis 5 squared plus 3.5 times 5. And then I don't really need the plus 0, but there it is in case you wanted it. So we get 5. So at 5, 5, this is the point on the parabola. This is the ball. The ball hits at 5, 5. So the question becomes, does it hit the wall at the very tippy top, which it will not because the wall's at 5, 6, or will it hit it on its way up or its way down? Well, let's take a look at our parabola. We know it hits at 1, 3. We know it hits at 2, 5. And it also hits right here at 3, 6. But then they tell us that the wall, there's a wall that happens, and the top of the wall is at 5, 6. It has nothing to do with our actual, this is just the wall. It has nothing to do with the actual ball itself. Now, they tell us that 5, 5, because we used our equation to plug in 5 and got 5, that's actually where the ball hits. So, to me, If 5, 6 is right here at the top of the wall, our parabola doesn't go that high. Our parabola goes to 5, 5. So does the ball hit the wall at the very tippy top? No, it can't, because our ball is at 5, 5. So does it hit it on its way up? No, because it goes all the way up to 3, 6. Or does it hit it on its way down? It has to hit it on its way down because the top of the wall is taller than where the ball actually hits. So I'm going to write on the way down. It hits on the way down. Okay, because it doesn't actually hit at 5, 6.